Welcome to this M1 video on tilting. So when we talk about tilting, we're talking about like when you've got rods and beams that are attached or resting, attached to ropes or resting on pivots. So for example, I've got this beam here, AB, and it's resting on these pivots C and D. And this is the reaction at C, and this is the reaction at D. And let's call it a uniform rod of weight 20 kilograms. So I've got this scenario. Then imagine I have a man that stands here, and he weighs, I don't know, 80 kilograms. And by him standing here, this beam, this rod, is now about to tilt about C. So that means it's about to tilt. So this end is about to go up in the air. Hasn't gone up yet, but it's about to. And when it's about to tilt, this normal reaction disappears. Okay, this RD is equal to 0 because it's about to tilt. Okay, and that's what tilting is. Okay, same thing happens if I've got, the beam and it is attached at two ends by two ropes. It has a weight here, and again, we have, let's call it C and D, and we add a particle of weight, I don't know, 50 kilograms here, and then this is about to tilt about D. So when it's about to tilt about D, it's like that rope isn't attached because it's now in equilibrium without that, because it's about to tilt about D. And that there is what tilting is about. It helps us work out problems, okay, just by eliminating a reactional force or a tension in a rope or a cable. And that's really kind of the only new thing that's been added. Everything else within the question, taking moments, resolving vertically, those things you still carry on doing. This now just gives us another scenario, okay, which we have to be aware of. So let's look at the first example. So I have a uniform beam AB. So let's make this AB. Of mass 40 kilograms, so that 40 kilograms is in the middle because it's uniform, and length 15 meters. Rests horizontally on supports C and D. So C and D. And these are at where this is 4 meters and CD is 8 meters. And then we got a reaction C and a reaction D. Okay, so this is the scenario we've got at the moment, and the total length is 15 meters. So 8 plus 4 is 12. So this leaves 3 meters at this end. So when a child stands at A, the beam is on the point of tilting about C. Find the mass of the child. So a child stands here at A, and we'll call it mg, and it's about to tilt. So now we can get rid of this normal reaction at D. Okay. So now we need to find the mass of the child. So obviously if we resolve vertically, we'd have RC and M would be two unknowns, which wouldn't help us. But if we take moments about C, we'll eliminate RC and we're just dealt with the mg. So mg times 4 is going to pull it one way, and 40g times, now it's halfway is 7.5, and that's 4, so this must be 3.5. Okay, so 4mg equals 140g. Cancel the g's. 140 divided by 4, so m equals 35. Okay, and this will be 35 kilograms, because I've done mg, so m would be the mass. And that there is the first example done. Hopefully you kind of followed that and you can see what happens when it's tilting. Let's have a look at the next example. So this time I have a non-uniform rod of AB. So AB of length 12 and weight 50 newtons. Is suspended from a pair of light cables attached to C and D, where AC equals 2 meters and BD equals 3 meters. So that's the tension at C and that's the tension at D. When a weight of 20 newtons is hung from B, so 20 newtons, the rod is on the point of rotating. Find the distance of the center of mass of the rod from A. So when we hang a 20 newton mass here, weight here, it's at the point of tilting, which would mean that it's going to be about D. So C we would get rid of, the tension at C. So the 50 newton weight is somewhere here between C and D. And of course, we need to find the distance from A to it. But for now, what I will do is find X, which will be the distance to D. Okay, so what I'm going to do here now, it's about to rotate, so we can get rid of that tension in C, and we can take moments about D. So that will mean 20 newtons times 3 will be equal to 50 times X. So 60 equals 50X. Therefore, X equals 1.2 meters. So if I look at my diagram now, this is 1.2 meters. So the distance from A, therefore distance center of mass is from A is, and it's going to be a length of 12 meters minus the 1.2 plus 3, and it's 7.8 meters. So that is the distance the center of mass is from A. Okay, so hopefully you followed that. This one didn't specifically say it's rotating about D, but you could figure out that it was going about D because they then added the weight to B. Okay, adding a weight here will lift it up at this end. So it's rotating about this point, which means that this tension is the one that's disappearing. Okay, so hopefully you followed that. It wasn't too difficult. Now, before we get into the questions, don't forget to like this video if you found it useful, subscribe and hit that join button. Otherwise, let's look at the questions. So I've got 3 questions for you in this video, all past paper questions. So pause the video now to have a go at 1 and 2. And pause the video now to have a go at 3. Welcome back. Let's have a look at the solutions. So we've got a uniform plank. So in the middle of this plank, we've got 100 G. That's the reaction at A. That's the reaction at B. Okay, a man of mass 80 kilograms starts walking from one end of the plank A to the other end. Find the distance he can walk past B before the plank starts to tip. Okay, so as he's walking along here, it's fine, and once he gets on this section, his weight's going to pull it down and it's going to start tipping at A. So what we're looking at is the man's mass is over here, 80 Gs, and we're looking at the point where RA equals 0. Okay, and what that distance is. So we want this distance, past B, isn't it? So we want this distance here. Let's call this X. So taking moments about B, and we have 100 G times. Now this distance here is 5 meters because it's in the middle of the midpoint of the plank. So this must be times by 2 meters. And then the 80G is times by X. So we get 200G equals 80XG. Now the G's will cancel, leaving me 80X equals 200. Therefore X is 200 divided by 80, which is 2.5 meters. So the man can travel 2.5 meters past B. And there we have the first question done. Now let's look at question 2. So we've got a non-uniform beam PQ of mass M and length 8A, hangs horizontally in equilibrium from 2 wires M and N. So that will be the tension in M and the tension at N. And PM is A and QN is 2A as shown in the diagram. The centre of mass of the beam is at the point O. So this is the centre of mass, and it is mass M, so mg. A particle of mass 3/4 m is placed on the beam at Q, and then the beam is on the point of tipping about N. Okay, So 3/4 M is put there, so 3/4 mg, and then it's about to be tipping about N, so this disappears. So now what I've got is I can take moments about N. So taking moments about N, and we get 3/4 mg times by 2a. That's going to be equal to, now let's call this ON, well, let's call it X. So that's going to be equal to mg times by X. So 3/4 times by 2 is 3/2 mg equals X mg. And oh, that's the A as well. So M's will cancel, G's will cancel, so X equals 3/2a. And that is what we wanted to find for part A. Now let's look at part B. So the particle is removed and replaced at the midpoint. So 3/4 mg is replaced to that point. Okay. And the beam remains in equilibrium. Find the magnitude of the tension in the wire attached at point N in terms of G. So we want to find tension at point M, so we can take moments about M. So the forces acting down are going to go one way, so we've got 3/4 mg multiplied by, now it's 4a from P minus this A, so this will be 3a there, so this will be times by 3a plus mg. Now this was 1.5a, 1.5a plus 2a is 3.5a plus this a is 4.5a, and the whole distance is 8a, so that leaves me with 3.5a from there to there. So that is times by 3.5a, and then that equals, so those two are going down, and then we have Tn, and that is times by 3.5 and the 1.5, so it's going to be 5a. Okay, so that is what I've got. Let's simplify it. So I got 23/4 mg equals Tn times 5a. So the a's will cancel. Let's divide by 5. And we get the Tn is 23/20 mg. So we found the tension, magnitude of the tension in the wire point N in terms of G. It's in terms of mg, but it's the same thing, I think. Yeah, just check the solutions to this problem, and that is the answer. So there we have part B and question 2 complete. Okay, so question 3, we have a uniform beam AB its weight is W newtons and its length is 14 meters. So this is 7 meters either side. Okay, it hangs in equilibrium in a horizontal position from 2 vertical cables attached at points C and D. So let me get rid of the 7s for now. So 2 vertical cables attached at C and D, where AC is 4 meters and BD is 6 meters. Okay, W is 7 meters from either side, so this is 1 meter and this is 3 meters there, and that gives me my 14 meters in length. A weight of 180 newtons is hung from A. So 180 newtons, that's W newtons, is hung from A, and the beam is about to tilt. So we got TC, but TD equals 0. Okay, at one point, and then we've got the weight is removed and a different weight is hung from B and the beam does not tilt. Find the maximum value of V. So first of all, let's find the weight of this beam. So we're at the point of tilting, we're going to take moments about C. And that gives me 180 times 4 is equal to W times 3. So 180 times 4 is 720. So divided by 3, so W equals 240 newtons. So now I've worked out W. Now, this 180 weight is removed from A, and a different weight of V newtons is hung from B. Okay, and this W now is 240, isn't it? So this is our scenario now, and this is no longer equal to 0 here. So the beam does not tilt. Find the maximum value of V. So let's assume that the beam is going to tilt. So it's going to be about D and C is going to disappear. So when C disappears, we're going to take moments about D. So we've got 240 times 1 going down, and then we've got 6 times V. So V equals 240 divided by 6, which is 40 newtons. So V is less than 40 newtons. Okay, doesn't equal it. Now, it is 40 newtons, sorry, because at 40 newtons, it's about to tilt. So anything over 40 newtons will make it tilt. So yeah, it's 40 newtons. And that is question 3 done. So if you found this video useful now, hit that like button. Subscribe if you are yet to do so. And if you're willing and able to help me out financially, give something a little back to me, then hit that join button, even if it's just for a month. And this is the final video in the M1 series of lessons. There are videos recapping each individual chapter in the book and some of the past papers. So stay tuned for those.